Hi everyone, my name is Dominique Malgeri, and my project was on stock market prediction with classification. Stock market prediction is the task of understanding the stock market behavior and forecasting its future prices. It can be treated as a machine learning problem and solved with supervised learning techniques using historical data. In my case, I fed historical stock market data to models and I trained them so that they could predict whether the price would rise or fall in the next day for two companies, Apple and Procter & Gamble. I used two types of models, classical machine learning models and neural network-based models. The classical machine learning models are trained by handcrafted features which are calculated from the historical stock data, and the neural network-based models are trained by raw features from the historical stock data. The question I pursued was about which of these scenarios produced a better prediction accuracy. The classical models trained with only handcrafted features, the neural network models trained with only raw features, or both the classical and neural network-based models trained with both raw and handcrafted features. My initial hypothesis was that the neural network-based models with only raw features or a combination of raw and handcrafted features would have better prediction accuracy than the classical machine learning models. I got my data set from Yahoo Finance and I analyzed the time period from 2000 to 2020. I trained my models with the first 64% of my data. I used validation with the next 16% of my data, and I did predictions on the final 20% of my data. The classical machine learning models I used were SVM, KNN, DT, LR, and XGB, and the neural network-based models I used were RNN with LSTM layers, CNN, and FFNN. The handcrafted features I input into my model were the average volume over the previous 5 days, volatility, average volatility over the previous 5 days, and I included a binary value of the company, 0 for Apple and 1 for Procter & Gamble, just to differentiate between the data points. The raw features I input into my models were the closing price arranged in a window size of the past 5 days and also a binary value of the company. The type of prediction I did was binary classification, meaning that the models output a 1 if they were predicting that the price would rise in the next day, and the models output a 0 if they were predicting that the price would fall in the next day. The results of the trained models in different scenarios are provided on the following slides in terms of accuracy. I have also included the confusion matrix for each, and the best accuracy I recorded was 51.82%, which is slightly better than a random chance, and these results indicate that stock prediction is a very tricky task. As you can see, these are the results of my classical models fed handcrafted features only, and the model that did the best was SVM with an accuracy of 51.66. These confusion matrices show that at the top left, the models correctly predicted a fall data point, and the bottom right shows that the models correctly predicted a rise data point. This is the result of my classical models fed handcrafted and raw features, and once again, SVM did the best at 51.66%. These are the results of my neural networks fed only raw data, and there was a tie between RNN and FFNN at 51.77%. These are the results of my neural networks fed raw and handcrafted features, and overall, out of every model I trained, FFNN did the best at 51.82%. I tried classical and neural network-based machine learning models, and I trained them with different types of features. The neural network-based models performed similarly to the classical machine learning models, and this is interesting because the neural network-based models are designed to handle sequential data like the stock market. This could be due to the complexity of tuning the architecture for neural networks. Also, the data might not have been sufficient for training the models. And additionally, the features were perhaps not indicative enough of the stock market trend for the models to make more accurate predictions. The features I chose for my research were based off research done by the IEEE, and in the future, I might choose more or different features for training the models. I would like to thank my capstone advisor, Professor Bahara Abbasi, for guiding me throughout this project.